Today's video, today we'll be looking into problem number 189 on Leetcode, and it is to rotate an integer array. Given an integer array nums, rotate the array to the right by k steps where k is non-negative. Let's look at the example given here. So there is an input array which contains 7 elements 1 to 7 and k is 3, which means that we have to rotate the array 3 times. So if you look at the explanation, so they are showing the contents of the array when you rotate it by 1, like if you rotate it once. So the first element will go to position number 2, and second element will go to position number 3, and third element will go to position number 4, and so on. So when you rotate it again, then all the elements will move to the right by 1 step. So and so on. So and this is the output after we rotate the array 3 times. So this is of medium complexity, this problem, and one of the easiest way to solve this problem is to have a second array of the same size and go through each element in the input array and place it in its final position in the second array. But the problem with that solution is that it uses more space. The space complexity will not be to the order of 1, because we need the need for space increases with the input array size. But that will solve the problem logically. Another way is to solve it using a Boolean array, and the third way is to solve it in place without using any extra memory. So I will not go into the details of first way where we use an extra array because it is kind of straightforward, but I will explain how we can solve this by using a Boolean array. So we have to declare a Boolean array which is of the same size as the input. And as you might be knowing, the initial values will be false in the Boolean array by default. So the purpose of the Boolean array is to denote if an element is in final position or not. So initially all will be false, which means that the elements are not in its final position. None of the elements are in its final position. So let's go to the first element, which is 1. So what is the final position of 1? It is 3 places ahead, which is the index of 1, which is 0, plus number of rotations, which is equal to 3. So this element will go to this place. So let's do that now. So element 1 is here, but we don't want to lose the data which is in index number 3. So we have to store it in a temporary variable. So let's say temp equals 4. So temp will contain the value which we replaced recently. So now we placed 1 in its final position. So we will move this flag to, we will change this flag to true. Next, we have to place this element in its final position. So what would be the index of this final position? It will be 3 plus 3 equals 6. So it will be in index number 6, which is here. So what was the element? Element is, we have stored it in temp, so which is 4. 4 went there, and before that we have to take the element in 7. Now our aim is to put 7 in its final position. So the index of 7 is 6 plus 3, 9. But since 9 is out of range, if it is out of range, if it is more than the total length of the array minus 1, then we have to do this minus 9 minus the total length of the array, which is 7, which is equal to 2. So value 7 goes into position number 2. Okay. Now what value was present in 2? It was 3, right? So temp will contain value 3. and 3 will go to position, it was here, so it will be 2 plus 3, 5. So it will come here, 3. So you would have got the logic by now. What we are doing is, we are taking an element, finding its final position and placing it there. But whatever value was present in the final place, we are storing it in a temporary variable. And now you would be thinking, how would we end this? Like, we cannot go in an infinite loop doing this. So what we will have is, we will have a counter, and when the counter reaches a number of elements, we will exit the loop. If you see here, we have to do 7 placements. So if the array contains 7 elements, we have to do 7 final placements. So we will keep a counter, and that will be incremented every time when we put an element in its final place. So when the counter reaches the total length of the array or total elements in the array, we exit the loop. That is one point. Second point is that, then you would be thinking, what is the use of this flag array? So it is to make sure that we are not moving an element which is already placed in its final position. So it will lead to a race condition, like infinite loop. So when we reach a position, first thing we have to check is if the value in that for that position is true. If it is true, we should not touch that because it is already in its final position. So let's look at the code for doing that. Now, to solve this problem using the flag array method, I've already written the code to make the video shorter. So let's go through it line by line. So this line is just to put a boundary check. So if the array length is 1 or the number of rotations is 0, then there is no action that is to be done. So we just return. Next is to get the total array length, because we are using it in many places. And then here we are declaring a Boolean array, and the size of the array is same as of the input array. And this is a temporary variable. And so number of rotations. So there is some logic here. So the number of rotations is k mod total length. So think about this. If the array size is 2, and if you say that I have to rotate it 6 times, then we are after 6 rotations, it came back to the same positions. Or say, let's say if the input array size is 5 and k is 12, which means if you have to rotate it 12 times, so after 5 rotations, it will come to the original place. Then again, one more 5 rotations, it will come to the original place. Then 2 more rotations. So actually, the real rotation that happens is 2 times. So that is why we are taking mode here. So we don't have to. So if you say that if k value is say 5,000, you don't have to rotate it 5,000 times, because it is when you rotate it after the length of the array, then it is coming back to the same position. So that is why you do mode. Then new position. These are some variables, and previous element. So when we start the previous element, the first element that we are putting in final position is the first element. So that is why I say nums of 0. Then final placements counter. So this is a counter to track of the number of placements we have already done. Okay, and this is another variable. So we can use it. We can write this method without using this many variables. I used many variables so that it is more readable or more understandable. Okay, so this is a while loop. So final placements counter should be less than the total length. So as I explained before, the number of placements we have to do is equal to the number of elements in the array. Okay, and then next check is what is the value of the flag array. So if it is false, then we have to do the movement. Okay, so let's see what we are doing. So we are taking the element in the new position into the temp variable. So the new position is, when we start, it is number of rotations. For example, if k is equal to 3, then we are moving the element in 0th position to the 3rd position. and then we are putting the previous element, which was the element in 0th position, in the new position, which is the 3rd position. Then we are incrementing the final placement counter. Then we are making the value of the flag array position to true, because we have done the final placement. We don't have to do anything in that position anymore. Then next we have to find the new position. New position is new position plus number of rotation more total length. Okay, why we are doing more total length is that because it can go beyond the length of the array. Then previous element is temporary element. Okay, so then we are going back to the loop again. Okay, in the else condition, if the what we will do when if the flag position is true, which means that if the element is already handled, then we have to go and check. We have to increment the new position by 1, and we have to see. We have to try and see if that element is already handled or not. So again, here this is just a check to make sure that if we are going beyond the length of the array, then new position is 0. Then previous position. So we have to find the previous position also. Previous position is new position minus number of rotations. Again, if it is going less than 0, then it is total length plus previous position. So then previous element is the element which is in the previous position. Then if we loop through this, say if the number of elements are 7, and if we loop through this 7 times, then we get the final output. We ran the code in Leetcode, and it got accepted, and the runtime is 3 milliseconds, and the memory usage is 57.61 MB. So if you see here, runtime is not that great, but it got accepted. Okay, so now let's look at the best solution. How we can solve this in place without using extra memory. So if you look at the input and output, what is essentially happening is that the numbers are moving from left to right, and the numbers which are in right place, right position, right side is coming to the left side, which is essentially reversing it. It is just left side elements are going to right and right side elements are coming to left. So it is kind of reversal, right? So let's reverse the array first, which is 7, 6, 5, 4, 3, 2, 1. Okay, now so what is the value of k? K is 3. So let's divide this array into 2. And let's reverse those subarrays. So if you reverse it, it becomes, so if you reverse this much, let's see what will happen. It becomes 5, 6, 7. And if you reverse rest of the array from here to here, the value is 1, 2, 3, 4. So that's it. We just need 3 reversals, and let's see how we can code this. The code for solving it through rotation way. So initially we are just getting the total length of the array in a variable. You don't have to essentially do this, but I just used a variable so that it is more readable. Then we are finding the number of rotations, which is k mod total length, and so this is a boundary condition check. If the total length is 1 or k is equal to 0, then there is nothing to be done. We just return. So then we are doing 3 reversals. So first we are reversing the entire array. So if you see here, I have written a small method to implement the reversal, and the inputs are the array and the left pointer and the right pointer. Okay, and if you see the logic here, we have a loop which says while left less than right. Then we are taking taking the right side element into a temporary variable. Then we are assigning the left side variable into the right side, in the right side position. Then again we are assigning the temporary variable to the left side position. This is just reversal, and we are just incrementing left pointer, then decrementing right pointer, and the condition here is at left less than right. So this is to reverse a given array from left to right. So using this logic, we are doing 3 reversals. First we are reversing the entire array. Second, we are reversing the array from position 0 to k minus 1, like the first 3 elements. So if k is equal to 3, then first 3 elements. And then we are reversing the rest of the elements from kth position to total length minus 1. So the code is as simple as that. Let's execute this and see the code in Leetcode. And as you see here, the runtime is 2 milliseconds and the memory is 57.660. So this is this is how you do it in place. Thanks for watching.